Hello guys, my name is Muhammad Indra and my number metric is 312498. So first, let's begin with our basic sample data. We have a sample size of 24, a sample mean bar of $69.17 and a standard deviation of $7.94. With 23 degrees of freedom, n-1 and a standard 2-tail alpha level, our T critical value is $2.096. By computing the standard error, we find our margin of error to be $3.35. When we add and subtract this from our sample mean of $69.17, we find a 95% confident interval that range from $65.82 to $72.52. This tells us we can be 95% confident that the true population means falls within this window. Next, I conducted a one sample t-test to see if our population mean is significantly different from 70. Our null hypothesis states that the means equals 70. Our rejection criteria is set beyond a critical value of plus minus $2.096. After plugging in our numbers, our calculated t-statistic come out to negative 0.512. As you can see on the diagram, negative 0.512 falls right into the middle area, while outside the shade rejection zones. Therefore, we do not reject the null hypothesis. We don't have enough statistical evidence to conclude that the mean is different from 70. Test B. Testing if the mean study hours is 6. I applied the same method to test if the mean study hours equals 6. Following the calculations, our calculated t-statistics came out to $0.4397. Just like the previous test, this value sits safely within the non-rejection region between negative 2.096 and plus 20.96. Once again, we cannot reject the null hypothesis, meaning we cannot conclude that the mean study hours differ significantly from 6.
Assalamualaikum, my name Muhammad Afnan Farhan bin Muhammad Afzal Rizal. So, moving on to part 3, we wanted to see if there is a statistical difference between the quiz score of male and female student. We have two independent groups, each with a sample size of 12, giving us a combined 22 degrees of freedom. At a 0.05 significant level, our T critical value is plus minus 2.074. Our computed T statistic is negative 0.923 because negative 0.923 falls squarely between our critical boundaries. We fail to reject the null hypothesis. In plain terms, there is no statistical significant difference in the mean quiz score between male and female students in this sample. Finally, let's look at the ANOVA results, which we use to compare the means of 3 or more groups. Our between group sums of square is 997.583 with 2 degrees of freedom, giving a mean square MST of 498.792. Our within group sum of square is 451.0.750 with 21 degrees of freedom, giving an error of mean square MSE of 21.512. When we divide the treatment variance by the error variance, MST divided by MSE, we get a massive F statistic of 23.187. An F value this high vastly exceeds standard critical value. This means there is a highly significant difference somewhere between our group means, allowing us to confidently reject the null hypothesis of equal means. So, to summarize, our single sample and two sample t-test show no major deviation from our hypothesis value or between genders. However, when comparing multiple group using ANOVA, we found a very strong statistically significant variance between them. Thank you guys.